Before we present our project, we'd like to briefly go over our main objective of our project by visually showing a storyboard we made to make things easier for you to understand. For the first storyboard, we have regular traffic involving our drawbridge mechanism, which just so happens to be smart because of its automated features. Storyboard 2 shows an approaching boat, causing all traffic to come to a halt due to the ultrasonic sensor detecting it. It will then trigger the bridge to draw up so that the boat may pass. Storyboard 3 shows the drawbridge going up to a certain angle based on the boat's height, allowing fast passage for the boat. Storyboard 4 shows the traffic moving across the bridge simultaneously with the boat still in the background, just to show that the bridge is able to close up fast enough for less traffic time. Storyboard 5 shows traffic was able to make it to the other side of the bridge and the boat would be nowhere to be seen. Overall, the objective of this project is to reduce traffic time by using sensors and actuators to make this happen.
Hello, my name is Diego, and I'm going to talk about the production of the project. So we first started off with the 4-bar mechanism, as you can see in the slide. And then once we found out our lanes and our angles, we just built the bridge itself. Once we built the bridge itself, we wanted to do some modifications so to make it easier for us. You can see here in a short link, we connected it together with the straight bar, and it'll be easier for us because then we could just only use one servo, and then we use these type of joints to connect all the links together. And then our final product is here in the bottom right. You can see there's a servo mount right there, and then we also made mounts for our ultrasonic sensor and also for the accelerometer.
So here's our drawbridge, and as you can see, all the components are either connected to it or some are mounted. So starting with the first component that we used was the servo. This servo was used to lift the bridge at a certain angle based on the boat's height. Then we used another servo. This servo was used to rotate the ultrasonic sensor, so the ultrasonic sensor scans the boat's height and gives us the right height, which is then converted to an angle. We also used an accelerometer as shown below. This was used to give us the angle of the bridge based on what position it is currently at, and then it's given as an angle. And another extra feature we used was a potentiometer, which is connected to the microcontroller. This was used to give the user manual control just in case he wants to control the bridge orientation rather than allowing the ultrasonic sensors to do it for him. And then the rest is the wiring and then the microcontroller.
We strive to make our program as efficient and readable as possible. The majority of the code was used to declare servos, sensors, and variables. To increase functionality and speed, a dictionary of values correlating drawbridge angle to necessary servo angle was made, rather than calculating in real time. For better readability and speed, we made sure we distinguish between using global/local variables, as well as implementing functions to simplify our code. Our most important code includes our scanning function as well as the core while loop of our program. Our scanning function tells the servo controlling the ultrasonic sensor to scan from -60 to 60 degrees, while keeping track of the maximum height and necessary angle the drawbridge should be set at. At the end, the function returns the necessary angle. In the core while loop, we check if we should use manual control, the potentiometer, or execute the scanning function. Both scenarios merge to setting the drawbridge servo to the correct angle based on our dictionary, as well as verifying the drawbridge is at its correct place using the accelerometer, making adjustments if necessary.
All right, stop the code. That concludes our presentation. Thank you, and this is Fall 2025.